Hello, my classmates. I am Miss Shen Lawei. Today, we are going to learn the course of Water Pollution Control Technology, Module 4 Advanced Processing Technology, Section 1, Coagulation Technology. In this section, we mainly study four contents. The first is a brief introduction of coagulation technology. The second is to understand the application of coagulation technology in water treatment engineering. Third, the principle of coagulation. Fourthly, it is to understand the common coagulant and coagulant aid types. Before learning coagulation, let's give you an example. Help students understand the application of coagulation technology in water treatment engineering. For example, the tap water we drink every day, clear and transparent in appearance. You can't see any suspended matter. Some students also know that waterworks generally use surface water, that is, what we call river water, lake water and reservoir water as water sources. Several waterworks in Ganzhou, it uses Ganjiang River water as its water source. Some students have also been to play along the Ganjiang River. It can be found that, whether it is sunny or rainy, the river of Ganjiang River, the water quality is relatively turbid. So how does the waterworks put the turbid river water, treat it into clear and transparent tap water? This PPT shows the traditional treatment process of waterworks. It includes four processes: coagulation, sedimentation, filtration and disinfection. Coagulation is the first treatment process. It is also a treatment process that plays an important role in the whole process. It is precisely because of the coagulation process that it makes the turbid river gradually clear, so that we can use clean and transparent tap water every day. Waterworks with surface water as water source. Coagulation technology is indispensable. Therefore, coagulation technology plays an important role in tap water treatment. Now let's look at what coagulation technology is. Coagulation is an important technical means for tap water purification and sewage treatment. The purpose of coagulation treatment is to remove water, fine suspended solids and colloidal substances, make the water clearer and more transparent. The treatment process includes coagulation and coagulation. The coagulation process involves destabilizing the colloid, and the process of aggregating destabilized colloids into tiny floc. The flocculation process refers to the microflocculation under the action of flow force, the process of colliding with each other to form large floccules. Then these two processes often occur at the same time when coagulation occurs. Only in this way can the suspended solids in water be removed and the turbidity be reduced. Next, we combined with coagulation experiment. Let everyone intuitively understand the phenomenon of coagulation. The coagulation experiment is mainly carried out with 6 stirrers. Firstly, the simulated wastewater is measured by beaker. The wastewater in the picture is that we are in the laboratory, made from pure milk and tap water. When the wastewater is taken away, add a proper amount of coagulant to the water. Subsequent stirring. The stirring process is divided into 2 parts: fast stirring and slow stirring. The purpose of these 2 stirring is different. When it's about to stir, we can find that small particles have appeared in the water. Then enter the slow stirring stage. The particles in the water are like snowballs. It's getting bigger slowly. At the same time, we can also find that wastewater from the beaker has become clearer and more transparent. Unlike before the experiment, it is a turbid state. When stirring stops, it enters the precipitation stage. The large particles produced will gradually precipitate. Everyone compares the water quality before and after the experiment. It can be found that most of the suspended solids in the water have been removed. The wastewater after coagulation experiment is relatively clear and transparent. Coagulant is added and stirred. Phenomenon of wastewater changing from turbidity to clarity. It is the coagulation phenomenon we usually talk about. Other pollutants in the water, for example, organic matter, nitrogen and phosphorus, etc., pollutants causing eutrophication of water bodies. It will also exist in a suspended state. Therefore, while removing suspended solids, cod, BOD, nitrogen and phosphorus contaminants in water, it will also decline accordingly. Therefore, coagulation technology is in the process of sewage purification, a very effective technical means. In addition to the tap water treatment we mentioned just now, it is also an important means to treat some industrial wastewater, for example, animal husbandry wastewater. The concentration of suspended solids in animal husbandry wastewater is very high. Wastewater treatment stations in many farms. Coagulation technology will also be used first. Remove SS, that is, suspended solids from water first. Then biochemical method and biological method are adopted. Advanced treatment of other pollutants in sewage. Through the study just now, we know the experimental phenomenon of coagulation and the application of coagulation technology. Next, let's learn the principle of confusion. If you are interested, you can take a beaker, get a glass of lake water from Lishwe Lake in the school, then observe. It can be found that many fine suspended solids exist in the lake water. No matter how long you stand still, those suspended solids will not settle down. Why is it difficult for suspended particles to precipitate? Because of those tiny colloidal particles suspended. It has stability. Viscose colloidal particles in natural water, and the colloidal protein and starch particles in sewage all have negative charges. Colloidal particles with the same charge will produce electrostatic repulsion. Pairs are mutually exclusive, so that colloidal particle cannot aggregate with each other, while maintaining a stable state for a long time. So it gives us the feeling that this water, it will remain in a very cloudy and opaque state for a long time. If you want to remove suspended matter from water, then the stability of the colloid must be broken. As we mentioned earlier, the coagulation experiment, coagulant can be added to water by compressing double cushion, adsorption bridging and net catching. Make the particles in water clump into large particles and precipitate, so that colloidal particle lose stability. The compressed electric double layer we mentioned just now is to add electrolyte to water, for example, iron salts and aluminum salts. The purpose of compressing the electric double layer of colloidal particles can be achieved, thereby eliminating or reducing the electrokinetic potential of the colloidal particles. Make colloids collide and coalesce, thus losing stability. Adsorption bridging is to add trivalent aluminum salt or iron salt to water, and other polymer coagulants. After being dissolved in water, high molecular polymer is formed by hydrolysis and polycondensation reaction. These polymers have linear structure. Adsorb and bridge with colloidal particles to make colloidal particles coalesce. The net catching refers to the flocculants such as iron salt and polyaluminum chloride. When added to water for flocculation experiment, hydrolyzed precipitates can be produced. These sediments are in the process of sequential sedimentation. It can reduce the colloidal particles in the net catching water and make the colloidal particles coagulate. In the process of coagulation, compressed electric double layer, adsorption bridging and net catching, the three functions often exist at the same time. Therefore, there will be obvious coagulation phenomenon that small particles hold together and become large particles. In order to make the water change from turbid state to clear and transparent state. Next, let's learn several coagulation processes. Chemicals to be used. There are mainly coagulants and coagulant aids. What is a coagulant? It is customary to refer to coagulants as agents that can play the role of coagulation and flocculation. The coagulant aid refers to when the coagulant cannot achieve good results. Some auxiliary agents can be added. Improve coagulation effect. This kind of auxiliary agent is what we call coagulant aid. Coagulants can be divided into inorganic coagulants and organic coagulants. There are few varieties of inorganic coagulants. However, it is widely used in water treatment applications. They are mainly water-soluble bivalent and trivalent metal salts, such as iron salts, aluminum salts, and hydrolyzed polymers. The common inorganic coagulants are polyaluminium chloride and polyferric sulfate. Polyaluminium chloride is an inorganic polymer coagulant. It is between aluminum chloride and aluminum hydroxide, a water-soluble inorganic high molecular polymer, widely used in the field of drinking water purification. Polyferric sulfate is another inorganic polymer coagulant. Its morphological character is light yellow amorphous powdery solid, extremely soluble in water. 10% aqueous solution is reddish-brown transparent liquid. Polyferric sulfate is widely used in drinking water purification, urban sewage treatment and sludge dewatering and other fields. There are many kinds of organic coagulants. It is mainly organic polymer coagulant. There are two types, natural and synthetic. At present, the most widely used ones are mainly synthetic ones. Organic polymer coagulants generally have huge linear molecules. Its molecular links have strong adsorption capacity with colloidal particles in water. The coagulation effect is particularly outstanding. Common coagulant aids include polyacrylamide, sodium polyacrylate, and polyethylene oxide. Coagulant aids may or may not participate in coagulation, in a certain sense. In a particular water treatment process, acting alone as coagulant, but it can be used in combination with coagulant to improve, or chemicals that improve coagulation and flocculation, can be called coagulant aid. It can be an acid-base substance that adjusts the pH of water, for example, lime and sulfuric acid. It can also be a substance that increases the granularity and firmness of alum flowers, for example, activated silicic acid and bone glue. It can also be an oxidant substance used to destroy substances that interfere with coagulants, for example, chlorine and ozone, and so on. In the actual process, especially for the wastewater with high turbidity, it is often necessary to add coagulant and coagulant aid at the same time. Only in this way can the ideal coagulation effect be achieved. Alright, everyone. Today we mainly studied coagulation technology and related contents. This concludes the study of this chapter. Thank you all.